Boom! Welcome to another set of stimulating notes. This time on brain protection. See my background here. I'm in a classroom today. No tie. Something's wrong, you might say. It's all good. Let's get rolling. So the question is, why do we need to protect the brain and spinal cord? Let me move myself over here. Right there's good. Nervous tissue is soft. Whoa. Nervous tissue is soft and delicate, meaning the slightest pressure or the slightest movement of non-protection and it rubs against something, it'll be injured. All right, and the thing about nervous tissue is it's amitotic, meaning it cannot divide. So once it's injured, it can't repair itself, which is why spinal cord injuries are permanent. The brain is protected by bone, the skull, membranes, meninges, and a watery cushion called the cerebral spinal fluid. It also has something called the BBB, which is the blood-brain barrier. All these things in corporation are what protect our brain and spinal cord. So what are meninges? Meninges are connective tissue membranes that protect whatever it's surrounding. And the plural is meninges, and one singular one is called meninx. The purpose of the meninges is to cover and protect the central nervous system, to protect blood vessels. They contain cerebral spinal fluid, and they form partitions in the skull, including dura mater, arachnoid matter, and pia mater. Now, if you did the dissection already, whether it's virtual, I don't know if it was in virtual or not, but definitely the one in person, we had to take the dura mater and peel it off of the brain. It's protective covering on the brain. Dura mater stands for tough mother, translated. So here's your information on dura mater. Dura mater, like I said, means tough mother. It is the strongest meninx. It surrounds the brain in two-layered sheet of fibrous connective tissue. So if you were to cut it and examine it, you'll see that it's double-layered. The more superficial of the layer is attached to the skull. That's the furthest one out. And then the other one is attached directly to the brain, which is why there's two layers. In case you didn't see the dura mater before, this is what it looks like. Right? Look, you've got this, looks like flap of skin that's on top of the brain. But this is what the dura mater is, this protective membrane that's over top of the brain. This is a sheep brain here. There's another matter called arachnoid matter. Sounds like spider, right? Well, that's what it looks like. Arachnoid matter is the middle meninx, forms a loose brain covering. It's separated from the dura mater by subdural space that has fluid. Beneath the arachnoid matter is a wide subarachnoid space where web-like extensions are located. So when someone discovered this, they saw it was spreading out across the brain like that. So they said it looked like a spider or spider web. This diagram here is cool because it kind of gives you in relation exactly where everything's located. So we've got the skin of our scalp, we got our head hair there, we got the periosteum, which is the bone, remember. We've got the wrapping of the bone, then we've got the bone itself, then we've got the dura mater, which is double layered. Then we've got the arachnoid matter, the pia mater, and then the arachnoid villus, blood vessels, and then you see everything's located here in kind of a layer. That just gives you an idea of where everything on your head is, boom, 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 all the way down through. The cerebral spinal fluid is abbreviated as CSF, and the CSF is around the brain, it forms a liquid cushion, and your brain floats in your skull, right? It's not tethered or attached directly, so it floats in there to give it some buoyancy. It makes it lighter. Why float? It reduces the brain weight by 97% and prevents the brain from crushing under its own weight. Brain's kind of heavy. If you picked up one of those sheep brains, I mean, they're pretty dense. So if they didn't have cerebral spinal fluid, it would cause damage. Having the brain float also gives us protection. Protects us from direct contact or direct blows. Picture yourself whapping your head on something. Fluid would allow it to move around and splash and not get direct contact with the skull. What you see here is the circulation of cerebral spinal fluid in the skull. So you've got the brain here, but look, we've got the protective layers here, and then these 1, 2, 3, and 4s show you where they're located around in the skull. 1 here, 2 here, 3, and 4. Just showing you how it flows through the subarachnoid spaces and where the fluid actually goes. Okay, that brings us to the blood-brain barrier. The BBB helps maintain a stable environment for the brain. It keeps out influx and change of hormones, amino acids, and ions. Oops. So what you're seeing here is the blood-brain barrier is kind of like its own cell membrane. It allows certain items in and out to get it to directly access to the brain, including some drugs. So when drugs are created, they have to be able to pass through the membranes of the cells and the blood-brain barrier to be effective. Well, that's all we got on this set of notes. So I'll see you back in class.